So this is the entire notes to the factoring section 8.5. And we're only going to do a piece at a time. Today, I wrote day one right here. We're going to do the class opener, which is simply distributive property. And then we're going to go over the first basic set of notes on factoring. And we're going to stop right here. And we're going to pick up this next time we meet. All right, so let's go back up here and do the class opener. It says, please use distributive property to simplify the following. Okay. So how do I do this? There's a 7 on the outside. I need to distribute the multiplication to the inside.
So you distribute the 7 into x and the 7 inside.
And what answer do we get?
7x plus 49.
Plus 49. Okay. How about number 2? What do I do? Distribute the 5q. 5q times 2 is what?
10q.
10q. You're welcome.
Minus 10q.
You get it? You're welcome.
I mean minus 10q.
All right, that wasn't even funny. No one got that. 5q, that's negative 25q squared. Perfect, yeah. Again, coefficient, multiply it by the coefficient, you get the coefficient. And then the variable q times the variable q, q squared. Perfect. And of course, we can't combine these because they're different terms. Now, what we could do, if we wanted to, is put them in order. Let's do a negative 25q squared first and the positive 10q second. That's the only thing you could do. You could arrange the answer so it'll look nicer, so it'll be in standard form, highest exponent down to smallest. All right, number 3, we actually have 2 variables involved here. 8a times x is simply that, 8ax. Now, if you're confused about that, again, you're multiplying the coefficient times the coefficient. The coefficient 8 times the coefficient, there's an invisible 1 right there. So 8 times 1 is 8. And then when you go a times x, that's just a times x. And now let's distribute the 8a to the 7. So 8a times negative 7, that'll be a negative 56 with an a. And that's it. Number 4. It's getting a little crazy. Still easy though. We're going to take this x. X times 1, that's x. X times xy, that's going to be x to the second y. X times x squared, y squared? X cubed, or x to the third, y squared. Perfect. Too easy. Now, of course, none of those we could combine because there are none that are alike. Let's move on to the last one here. So on this one, we're going to distribute the 4x squared times 3x to the 5th. 4 times 3 is 12. X squared times x to the 5th is x to the 7th. So let's distribute the 4x squared to the negative 2. That's negative 8. And you bring down the x squared. And 4x squared times positive x to the 3rd, that is positive 4x to the 5th. The only other thing to do is to write it in standard form, which means we're going to switch these two. We're just going to switch them, the order. Final answer is 12x to the 7th, that's the highest exponent, plus 4x to the 5th minus 8x squared. That's it. Okay, so we know how to distribute a monomial into a polynomial. And that's an essential skill for what we're going to be doing right now. We're going to start factoring, all right? Factoring. What is factoring? It's simply doing distributive property backwards. It's kind of like having the answer and trying to find the question, right? So I'm going to give you something like this answer, and I want to ask you to factor it, which is a reverse distributive property, so you could get to this original question. All right? Let me show you what I mean by that. Let's continue reading right here. There are many different forms of factoring. The first one we're going to cover in this class is basic factoring, pulling out the GCF. That's the GCF that represents greatest common factor. So pull out any common multiple in all terms of the polynomial. Example, let me do this one, and then you guys follow along in your notes. I have a binomial here, right? 2 terms. Now I need to ask myself, what's in common in both terms? Do I have an x in both terms? No. Do I have the multiple of 8 in both terms? I mean, right here, 8 times 1 is 8, but is 8 times something 12? No. Okay, so the multiple of 8 is not in both terms. Is there a multiple of 2 in both terms? Yeah, okay, multiple of 2 is in both terms, but we want the greatest common factor, not just any common factor, right? The common factor is 2, but we want the greatest common factor. So what number is bigger than 2? 4. So we're gonna, the GCF here is 4, and we're gonna do this. We're gonna put that 4 on the outside and put some parentheses right there. And this is what I mean by doing a reverse distributive property. Once you think about this term and that term and you're like, oh, they have a 4 in common in both terms, I want to pull out that 4. What would be left on the inside? So if I pull out a 4 from an 8, what would be left? In other words, 4 times what would take you back to the 8x? 4 times 2x will take you back to the 8x. Now how about over here? 4 times what will take you back to the... There you go, -3, -3. And that's it. We're done. We factored. What? That's easy. So if you understand how to distribute, all you got to do is do that backwards. Now, let's say you weren't too sure, like I don't know if I did this right. What could you do to double check? You could distribute, right, and see if it actually gives you the above answer. Yeah, 4 times 2x is 8x, 4 times 3 is 12. So I mean, you know that you did it right. Let's move on. Well, let's move on to number 2. Follow along with me right here. We have a trinomial, right? 3 terms. So let me ask you, what do you think's in common here, here, and here? Give me anything that's in common. There's definitely y's and there's x's, right? Now, again, it's called GCF because you want the greatest common factor. So if you just say, I'm going to pull out a y, that's a factor. Yeah, that's in common, but it's not the greatest common factor. So the greatest amount that you could pull from all 3 terms at the same time. Is there, like right here, there's a 3, there's a 6. If there were a 9, I could pull out the coefficient 3, but there is no number in common. There is no coefficient in common in all 3 terms. But I do have x's. I have 1x here, 1x there. Oh, I don't have any x's here. So I can't even pull out an x. I can pull out a y, right? So how about this? Let's all do this. Let's put parentheses right here. And I'm going to pull out a y, but the question is, what's the greatest amount of y's I could pull out? Could I pull out 5 y's? I can pull it out from here and from here, but not from here. So what's my greatest amount of y's that I could pull out from all the terms at the same exact time? 2, right? So we're going to say y squared. That's what's going to be on the outside. That's the greatest common factor. So if I do pull out a y squared from here, from the whole first term, what's going to be left? Okay? And again, in other words, y squared times what will get us an x y to the 5th? Well, if you want an x up here, you're going to have an x in here. X, y to the 3rd. Perfect. Right? X, y to the 3rd. Now, how about the middle term? If I have a y squared times what will give me a -6 x y to the 7th. -6 x y to the 5th. That's right. And the last one, y squared times what will get us a 3y squared? Well, it's already y squared. Y squared times 3 will get us a 3y squared. So let's put a +3 right there. And we're done. Okay, let's try number 3 right here. 3 terms. Is there numbers that are in common in all 3 coefficients? Like a multiple that's in common in all 3 coefficients? 4. Okay. So I was thinking maybe 8, right? 8, but right here this is not divisible by 8. So yeah, 4 is the greatest common factor when it comes to the numbers. Now how about x's? Are there x's in all 3 terms? Yes. What's the greatest amount of x's that I could pull out? 2. So I really have the 4 for the numbers, for the coefficients, and we said 2 x's. So 4x squared is the GCF. And when I pull that out of there, what would be left on the inside? In other words, 4x squared times what is 8x to the 3rd? 2x. And how about the next term? 4x squared times what gets you back up to here? -4x to the 3rd power. Perfect. And the last one, 4x squared times what, will get us back to here. Positive 3 just by itself. If I put an x, then it would be 4x times, or 4x squared times 3x. That'd give me an x to the third, and that's not what we have here, right? We have x squared. So it's just 4x squared times 3. That'll give us a 12x squared. Let's do another one here. 3 terms. Are there any x's I could pull out of all 3 terms? No. Is there a multiple of the 2, the 4, and the 5 that I could pull out? No. Yeah, the 2 and the 4 you could pull out of 2, but not from the 5. So now what are they asking us to do here? They're asking us to factor. Okay. So if we cannot factor, that's what we're going to write. We're going to write not factorable. Now, what does that mean? That means that you're not able to factor it. Not factorable. So sometimes you just can't pull out. There is nothing in common. Okay? All right, so now that you've seen me go through those, let's have you guys spend a couple of minutes trying to do the next 5. Go for it. So what we should all be doing is this. Like on number 1, you should put some parentheses right below the binomial. And then think, what's in common? What's in common here on the first term and the second term? What's in common that I could pull out here? 7. So go ahead and put that 7 on the outside. And then what would be left over on the inside? Right. And the thought process in your head, what should be happening is this. 7 times what gives you 7x? X, that's right. So you put an x in there. And then 7 times what will give you a positive 49? Positive 7, so plus 7. It's that easy, guys. On every single one of these, you're going to have to put the parentheses like this. Find out what's in common in all of your terms. There's only 2 terms here that you could pull out here to the front. So what's in common with the 10 and a 25? Definitely a 5. Okay, so let's put a 5. But there's more than just a 5. There's q's, right? What's the maximum amount of q's? Right here I have 1, right here I have 2. What's the maximum amount I can pull out at the same time from both? Only 1. So you're going to put 5q out there. Now once you pull out that 5q, what's going to be left over on the inside? This is the thought process. 5q times what gets you 10q? 2. And then 5q times what gives you a minus 25q squared? Minus 5q. And that's it. If you wanted to double check, if you did this right, go ahead and distribute. You will see that you get the above expression. Number 3. Put the parentheses, even before thinking about it. Put the parentheses and then think, what's in common here and here? Well, how about the 8 and the 56? I could actually pull out an 8, right? If you say 2, yeah, you could pull out a 2, but that's not the greatest multiple that you could pull out. So we could pull out an 8 itself. So I'm going to put an 8 out here. And also there's an A in both terms. So let's pull out that A as well. So 8A is the GCF. If I pull out an 8A, what will be left here and here? 8A times what gives me an 8AX? X. 8A times X will give me an 8AX. How about 8A times what gives me a negative 56A? Minus 7. And that's it. Easy peasy, lemon squeezy. Number 4, I have 3 terms. Do the parentheses. When they ask you to factor, do the parentheses. Let's see what's in common in all 3 terms. There's an x here, an x squared there, an x to the third there. I obviously have x's in all 3 terms. No y's on all 3 terms, just x's on all 3 terms. What's the maximum amount of x's I could pull out of all 3 terms at the same time? 1. Only 1, right? You can't say, like, oh, I'm going to pull out 2 x's from here, 2 x's from here. I'm going to pull out, wait a minute, there's only 1 x here. So the key is, what's the greatest value that you could pull out of all 3 terms at the same time? So only 1x. Now, if I do pull out that 1x, what's going to be left over on the inside? X times what gives me x? Really? X times x is x? X times x, yeah, x times x is x squared. So x times what will give me this first value x? 1, right? It doesn't change. So you need a 1 out there. Okay? Now how about this? X times what will give me an x squared y? Positive xy. Yeah? And then we go x times what gives us an x to the third y squared. Put a positive x to the second y to the second. And that's it. Now, the last one here, again, 3 terms. Put the parentheses. What's in common in all 3 terms? We have a 12, an 8, and a 4. We could pull out a 4. Okay, so let's pull out a 4. And how about x's? What's the greatest amount of x's I could pull out from all 3 terms at the same time? 2, right? There's 7 here. You might be thinking, I could pull out a 7. Yeah, you can't pull out a 7 from here. There's only 2 of them. Right? Right here, there's only 5. So the greatest amount of x's you could pull out of all 3 terms at the same time would be x squared. You could pull out x squared from here, you could pull out x squared from there, you could pull out an x squared from there, and that's what we're going to do. We're going to pull out an x squared. So now that we know the GCF, we're going to say 4x squared times what gives me a 12x to the 7th. 3x to the 5th. And now 4x squared times what gives me a negative x to the 2nd. That's going to give me a negative 2. And 4x squared times what gives me a positive 4x to the 5th. Positive x to the 3rd. Now you could put a 1 right here even though it's not necessary, right? I mean 4 times 1 is 4. You don't really need that 1. If you don't want to, don't put it. And that's it. Now, I don't know if you recognized, but the class opener questions, they're the same ones as what we did right now. Like up here, number 1, I asked you to distribute. You got the answer 7x plus 49. And down here where you guys tried it, number 1, I gave you the answer 7x plus 49 and asked you to factor, which gave you the 7 times x plus 7. Okay, so I hope we understand that factoring is simply a reverse distributive property. So all you're doing is looking at all your terms and seeing what's in common, putting some parentheses, pulling out that GCF, and then writing what's left over on the inside. So on my next video, we're going to practice doing exactly that on the first part of our homework. Only going to be doing 1 through 12.